Ever wonder how AI can learn from just a few examples? Like how a computer could recognize a cat in a photo, even if it's never seen one before. That's the magic of semi-supervised learning. And today, we're exploring a breakthrough called JSA that's changing the game. Here's the problem. Traditional AI models like variational autoencoders, VAEs, and generative adversarial networks, GANs, struggle with discrete data, think words, categories, or pixel values that jump between states. Why? Because they rely on gradients, which require smooth, continuous inputs. Discrete data is like a bumpy gravel path. The model can't feel the right direction. Enter Joint-Stochastic-Approximation autoencoders, JSA. These models directly maximize the likelihood of the data, making their predictions as likely as possible given what they've seen. Imagine guessing a friend's favorite song by adjusting your guess based on clues from their playlist. That's JSA. It learns by iteratively refining its assumptions, not just memorizing patterns. The key innovation: a decades-old math technique called stochastic approximation. Think of it as a puzzle solver that tests pieces one at a time, tweaking its strategy as it goes. This allows JSA to handle both discrete, like words or categories, and continuous, like pixel values, data seamlessly. It's like teaching a robot to paint. First, it learns brushstrokes continuous, then color choices discrete, all in one go. What makes JSA powerful? It directly minimizes KL divergence, a measure of how far the model's internal guesses are from the real data. This is like a team of detectives. One recreates the crime scene, the generator, while the other deciphers clues, the encoder. They constantly adjust their theories to avoid miscommunication. In tests on datasets like MNIST, handwritten digits, and SVHN, street numbers, JSA autoencoders matched or beat state-of-the-art models, even when using discrete latent spaces, which are simpler and more interpretable than continuous ones. This means AI can learn smarter from way more data, without needing every label. Imagine training a medical AI to spot diseases using thousands of scans, but only a few have doctor annotations. JSA makes that possible. Take the MNIST experiment. Researchers trained JSA on a mix of labeled and unlabeled data. The model created a manifold where similar digits clustered together, threes grouped, sevens nearby, with smooth transitions between them. This isn't just neat. It improves tasks like reconstructing blurry images or guessing labels with sparse data. How did they do it? The model first focused on labeled data, like memorizing teachers' notes. Then it used both labeled and unlabeled data to refine its understanding, like studying notes in classmates' messy notebooks. An optimizer called SGD acted as a digital compass, guiding the model toward better answers. The learning rate started fast, 0.001, but slowed over time, like a runner shifting from sprint to steady pace. Why does this matter? Labeled data is expensive and time-consuming. JSA shows AI can learn smarter with less supervision, making it ideal for real-world problems with messy or incomplete data. From medical imaging to self-driving cars, this tech could make AI more efficient and accessible. So next time you see an AI doing something impressive, remember, it might be learning from a mix of clues, not just perfect instructions. Thanks for watching, stay curious, and we'll see you next time.